So one of the wildest new features available in Flash Player 10 is the ability to dynamically generate sounds at runtime. So this is something that some community members like Andre Michel have been doing kind of through some hacks in the Flash Player. Well, Adobe has really listened to the community and has built into Flash Player 10 the ability to dynamically generate and manipulate audio. So I'm going to show you just a basic way in which you can do that. These APIs, of course, just like any that I'm showing you that are in the beta version of the player, may actually change in the release version, so just be aware of that. So again, I'm going to use TextMate, and you'll want to have watched my other two Flash Player 10 tutorials first. So I'm going to go ahead and create a new sprite subclass, and I'm going to call it Dynamic Sound. Just save it to the desktop. Okay, so here's the base of my project. Now, since I'm going to be using the sound class, I'm going to have to import flash.media. Okay, so what I'm going to make in this tutorial is essentially a dynamically generated sound that's based on my mouse position. So this is something that Keith Peters at Bit 101 did on his blog, and I'm kind of basing this off of his example. So some of this, what I'm going to show you, kind of requires that you know about audio, and there's a lot of audio terminology. I don't know about that, but again, that's the beautiful thing about Flash. You can take other people's code and just kind of manipulate it to create your own things. So I'm not going to be teaching you the in-depth topics on sound and the way it works. We're just going to create a simple project to show off how this new audio generation engine works. So first thing I'm going to do is I'm going to create my sound object, and I'm just going to call it sound and data type it to sound. So another property we need to create is essentially a value that as we go through our movie, we're going to be running through a loop, and we're going to constantly be adding an amount to this value, and it's going to determine the frequency or the pitch of our tone. So I'm going to create a variable, and I'm just going to call it noise for lack of a better word, and this is going to be a number. So again, this noise property is what's going to determine the pitch of our sound. Okay, so in the constructor here, I'm just going to set up my sound object. So sound is equal to new sound. So the way in which this new sound engine works is there's a new event of the sound class, and it's called samples callback. So basically what you start out with is an empty sound object, and then you fill it with a certain amount of sound data. Then as soon as the sound object has played, or it's almost done playing with the data that's in there, it's going to fire this event because it wants you to put more sound data in there. So this is going to happen repetitively. So this samples callback is the event that we need to listen for. So sound.add event listener, and it's event.samples underscore callback. And I'm going to have it call a function called onCallback. So now the last thing we need to do with the sound object is to simply play it using the play method. So again, this seems a little strange because we actually, in a typical scenario, we would load in a sound or something. Here, we're starting to play it with no data in it. But in this onCallback function, we're actually going to be populating it with some dynamic sound data. Okay, so let's quickly create this function. So it's going to be onCallback. And the event type is samples callback event. Okay, so what I'm going to do here, the first thing we need to do is, again, this is going to be called repetitively, and the sound object is expecting us to set some new data that it can play. And this is actually raw binary data. So there's a new property of the sound object called sound.samples callback data. So this property is actually, I have to spell it correctly. So this property is actually a byte array, and it's expecting us to write floating point values to it for the sound data. So we're going to be using the write float method. Now I'm going to leave this empty for now, because first we need to determine what the actual sound value is going to be. But it's important to note that we have to write a value for both the left and the right channels. So I'm just going to duplicate that line. Again, this is just stubbing it out. But essentially we have to write it twice, one for each channel. Now if we wanted different sounds in different, the left and the right speakers, we could make these different. But for our purposes, we're just going to leave it. So what we need to do is we need to create a for loop that's going to create at least 512 float values so that we can populate into that byte array. Now it can go as high as, I can't remember the number off the top of my head, but it can go much higher than that. And basically the way it works is the lower the number, obviously the less amount of data Flash has. So it has to do more work in order to generate the sound. If you do a high number for this for loop, essentially there's a lot more sound data to work with, so the performance will actually go up, but the latency increases, meaning if I were to make a change, it would take perhaps a second or even 2 seconds in order for the sound to come on. So just to keep it simple, I'm just going to create a for loop with the minimum amount of data. So unsigned integer, and I'm going to do I is less than 512. So again, you have to have at least 512, in this for loop. So then I++, and let's come down here. Okay, so now we need to find out which value we're going to write into this byte array, which will determine what sound gets played back. So what we're going to do is we're going to actually I need to set this noise property equal to 0. So we're going to start out at 0 for this value. And then we're going to set it. So I'm going to say noise, and again we want to add something to this value. So I'm going to do plus equal signs. Now what I'm going to do is I'm just going to take the mouse's X and Y position, and I'm going to use that to dynamically create a sound. Again, this is something that Keith had over on his blog, so you want to check that out for more details on that. Again, I'm not trying to explain all of the intricacies of sound here, because to be honest, I don't know what those intricacies are. So we're just kind of hacking around here for fun. So I'm going to take mouse X, and I'm just going to multiply it by mouse Y. And there's no reason that I did that other than just experimentation, and it kind of creates a cool effect. Then we need to divide that by 44,100. So where is that number coming from? Well, the dynamically generated sound in Flash Player 10 is at 44.1 kilohertz, which represents the highest possible quality sound in the Flash Player. And so that's essentially the sample rate for our sound. So we're dividing this value by 44,100, and then we're adding that amount to our noise property. Okay, so the fun doesn't end there though. So now what we have to do is we need to find out the angle. So essentially we're creating a sine wave for our sound. So first thing we need to do is to find out the angle of where it is. So I'm going to create a variable here. I'm going to call it sample. And now we're going to take that number we just calculated, so noise, and I'm going to multiply it by math.pi times 2. So 2 pi represents 360 degrees. So we're multiplying the value we created in the last line by 360 degrees in essence. So this will give us this sample number. Now, for what we actually plug into this write float method, we need to take the sign of that sample variable that I just created. So math.sign, and then pass in sample. And again, we're going to write the same exact value for the left and the right channels. So we could alter that if we wanted to, but I'm just going to leave it the way it is. So again, This is not, a lot of this may seem confusing, but the main thing is if you want to create just a constant tone, then this should just be a hard-coded value. If you want to change it based on any type of user feedback, then this is the piece that can be dynamic. Again, in a simple example like this. Okay, so I'm going to compile that, see if we have any errors. And we can see I'm fine, no errors. So I'm going to open up Safari and bring in my movie. Now we can hear, as I move my mouse around, we get some kind of R2-D2 Star Wars type of sound effects. And we can see with my mouse all the way upper left-hand corner, we have a low tone. And as I move it down, it's slowly going up to the point where we get some really interesting effects at the higher level. So basically, if you want to keep dogs away from your house, you can get some really high values that probably only animals can hear. So again, we can see that this is dynamically creating sound. If I just leave my mouse steady, we have a solid, a constant tone. So again, if we were to hard code that value instead of taking the mouse X and Y, we can get certain tones. But again, it's kind of cool that we can do this stuff in the Flash player. I'll leave it up to other people to create some compelling uses for it. But basically, again, I'm not going to describe all of the reasons why this works because, to be honest, I still need to find that out myself. But again, if you want to start hacking around with this, and again, keep your eye on the blogs for more explanations as to what all these values mean. I'll be looking out for those myself.